All right, so we're going to start chapter 1, section 5b. We're going to solve equations with complex numbers. Now, to actually solve these isn't any different from what we've seen in the previous section. Only here we cannot use any sort of factoring, right? None of these are going to be able to factor, right? So we're going to use instead any even root property, so that's square rooting both sides, completing the square, and quadratic formula. All right, and if you have a negative under the radical, right, like I keep saying, we're past no solution. You can't say it's no solution anymore. You have to rewrite your answer in terms of I. All right, so let's start with the first one. All right, x minus 2 squared equals negative 20 is something that we've seen in a similar format, right, except maybe we've seen this with a positive number, right? But now we're going to work with negative numbers, right? So if we want to solve this, hopefully we remember we have to take the square root of both sides, right? And the square root and the square cancel out, so we get x minus 2 equals plus or minus the square root of negative 20. All right, 1, don't forget the plus or minus, and 2, don't forget to simplify your answer. Right, so I'll do that after this next step. First, I want to get the x by itself. All right, so you get x equals 2 plus or minus the square root of negative 20. And we want to simplify our answer a little bit more. Right, first, if there's a negative under the radical, you can replace that with an I. Or let me use a different color, hold on. Yeah, if there's a negative under the radical, you can replace it with an I. So we get I square root of 20. And square root of 20 we can break up into the square root of 4 and the square root of 5. Right, and the square root of 4 becomes 2. So our final answer is going to be x equals 2 plus or minus the square root of negative 20 became 2I square root of 5. All right, so same exact process, just this time we have to simplify the i's. All right, so let's look at the next one. All right, like I said, similar process. We want to get our squared term by itself. In this case, it is. All right, so all we have to do now is just square root both sides. The square root and the square are going to cancel out, so we get 3x minus 1 equals plus or minus the square root of negative 48. All right, and then you want to get the x by itself by adding 1 to both sides. So you get 3x equals 1 plus or minus the square root of negative 48. And then you want to divide your answer by 3. All right, so then you get x equals 1 plus or minus the square root of negative 48 divided by 3. And lastly, we want to simplify our radical, right? So again, if you have a negative under the radical, right, you replace that with I. And square root of 48 can simplify into the square root of 16 and the square root of 3. Right, you can pick any two factors. You just might have to do a little bit more work to get to your answer, but any two factors is fine if you didn't recognize 16 and 3. All right, and then the square root of 16 becomes 4, and then the square root of 3 can't simplify, so our final answer would be x equals 1 4I square root of 3 divided by 3. All right, and you can leave your answer like that. It doesn't say to write our answer in standard form, right? So here it's fine. If you wanted to take it a step further and write it in standard form, remember this is not in standard form. Standard form is a real plus an imaginary, right? A plus bi. Right, so we get x equals 1 over 3 plus or minus 4I square root of 3 over 3. All right, and this would be your answer in standard form. We have our real and we have our imaginary. All right. Now looking at the next two examples, we can apply the even root property here, right? We don't have a squared term by itself, nor can we get it by itself because we have an extra x here. The other ways that you could do this are by completing the square or by the quadratic formula. Right, I like the quadratic formula. It works every single time, right? So hopefully we remember the quadratic formula is going to be x equals negative b plus or minus the square root of b squared minus 4ac over 2a. All right. So then we want to label here what's a. A is 1, b is 1, and c is 5. Remember, a is the number in front of the x squared, b is the number in front of the x, and c is your constant. So we just want to plug these numbers into the quadratic formula to get our answer. So we get x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 5 over 2 times 1. again, I just plugged in a, b, and c into our formula, right? 1, 1, and 5. And then simplifying this answer, we get x equals 1, or negative 1, plus or minus the square root of 1 squared is 1, minus 4 times 1 is 4 times 5 is 20, over 2 times 1 is 2. And now let's simplify a little more. All right, so 1 minus 20 under the radical becomes negative 19. So we get negative 1 plus or minus the square root of negative 19 over 2. All right, if you're not comfortable with the steps that I take to get rid of that I, you can always just split it up. Right, so this is the same as negative 1 plus or minus the square root of negative 1 times 19. And then here you should see that negative 1 becomes I. And then 19 can't simplify under the radical. All right, so we should get negative 1 plus or minus I square root of 19 over 2. And you can leave it like this. Okay, let's try the next one. Again, we can do it by either completing the square or by quadratic formula. I'm going to use quadratic formula. Again, it works every single time. And by completing the square, if we remember our steps, we want to subtract the 10 to both sides and then divide the b term by 2, but then you get a fraction here. Right, and I know you guys don't like working with the fractions. You'll get an answer, but I know that kind of messes some of you up, so you don't have to do it here. It will be easier here to just use the quadratic formula. All right, so let me go ahead and erase this and let's label, right? So we get a equals 1, b equals 3, and c equals 10. All right, and let's plug it into our quadratic formula, right? So we get x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 10 all over 2 times 1. All right, and let's simplify this a little bit. So we get x equals negative 3 plus or minus the square root. 3 squared is 9, minus 4 times 1 times 10 is going to be 40. And then divided by 2 times 1, which is 2. And now let's simplify a little bit more. All right, so we get, so we should get negative 3 plus or minus the square root. We want to simplify under that radical. 9 minus 40 is going to get us negative 31. All right, divided by 2. All right, and then again, if you see a negative under the radical, replace it with an I. All right, so our final answer, we should get x equals negative 3 plus or minus I square root of 31 divided by 2. And then there's your answer. There's nothing more you can do to it. 31 doesn't simplify. All right, so that's it for that problem. All right, let's keep going. So something like number 5, it's formatted as some of the previous ones where we have an x squared and everything on one side and set it equal to 0. Now you could use the quadratic formula here and say, okay, a is 1, right? But we're missing our x term. Keep in mind there's no x, right? So we say b is equal to 0, right? Because this is the same as if we were to say plus 0x, right? If 0 times anything is 0, right? If it's not there, you can replace it with 0, and you can still use quadratic equation if you would like, and you get c equals 25, right? So when you plug this in, then you should get the same answer as what I'm about to do, right? But I wouldn't do it this way just because you still have a squared term with no x term, right? When there's no x term, I would get the x squared by itself, right? So to do that, we want to subtract 25 on both sides. And then we get x squared equals negative 25. And now all we have to do is take the square root of both sides, right? So cancel out the square and the square root. We get x equals plus or minus. The square root of 25 is 5, and the square root of negative is I. Right, so we get plus or minus 5i as our answer. Right, and you could still do it with the quadratic formula, right? It would still work, right? X equals negative 0 plus or minus 0 squared minus 4 times 1 times 25 over 2 times 1, right? And you can simplify that if you would like. But you notice that that's not going to be the fastest way to do it every single time, right? Something like this, if you can recognize that you want to get the x squared by itself, then that's how you can do it. All right, And then I'll skip 6 for now. Let's try 7, right? Because this is something kind of similar, right? You could use the quadratic formula and say a equals 25. There's no x term, so we say b is 0 and c is 9 and plug it into the quadratic formula. That's fine. But again, you want to get your squared term by itself here, since that would be the most efficient way to do it. All right, so let's subtract 9 from both sides. So right now we have 25x squared equals negative 9. All right, and then you want to divide both sides by 25. And then now we have the x squared by itself. So we get x squared equals negative 9 over 25. And now lastly, to simplify this, we want to take the square root of both sides. All right, so square root of x squared just becomes x. And square root of negative 9 over 25. Hopefully we recognize that those are both perfect squares. 9 is a perfect square and so is 25. So we get 3 over 5, and then the negative under the radical becomes I. And don't forget your plus or minus. All right, so we get x equals plus or minus 3 over 5i. Again, if you did it with the quadratic formula, you should get the exact same answer, right? Upon a bunch of simplification, you should get the same answer. All right, but that's maybe not the fastest way to do it, right? There's a lot less work on the page now than compared to if we were to do it with the quadratic formula. And you can test it out yourself. All right, and you should verify that we get the same answer. All right, let's try number 6. Again, you can solve it any method. You can do it either by the quadratic formula or by completing the square. Now, I know I tell you guys I typically use the quadratic formula. Let's just try this one by completing the square, right? I maybe try it both ways just so that you guys can see. All right, so by completing the square, if we remember, we want our constant to the other side. So we should get x squared plus 2x plus a little space equals negative 9 plus a little space. All right, this one's not so bad to do completing the square because our middle term is an even number. Right, so when we do b over 2 squared, right, we're going to get not a fraction, right? So b in this case is 2, right? So 2 over 2 is 1, and then 1 squared is just 1, right? So we're just adding 1 to both sides. All right, so plus 1. And then this factors, right? The whole point of doing this is so that this side of the equation factors as a perfect square trinomial. So we get x plus b over 2. In this case, b over 2 is 1. So we get x plus 1 squared equals negative 9 plus 1 is going to be negative 8. All right, and now you just want to take the square root of both sides. All right, the square root and the square cancel. We get x plus 1 equals plus or minus the square root of negative 8. And then we just want to subtract 1 from both sides. So we get x equals negative 1. Plus or minus, let's simplify the square root of negative 8 as well, right? The negative under the radical becomes I, all right? And the square root of 8 becomes the square root of 4 times 2, right? So then the square root of 4 becomes 2, so we get negative 1 plus or minus 2 I square root of 2. All right, so that's what you should get for this answer. Now, if you did it by quadratic formula, that's also fine. I'll show you. Right, so in this case, a is going to be, a is going to be 1, b is 2, and c is 9. All right, so we should get x equals negative 2 plus or minus, write that better, negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 9 over 2 times 1. All right, so we should get negative 2 plus or minus 2 squared is 4 minus 4 times 1 times 9 is 36, negative 36. All right, square root of that over 2. And let's just simplify this a little bit more. We get x equals negative 2 plus or minus the square root of negative 32 over 2. All right, now let's simplify this radical. Negative 32 becomes I, and then 32 can simplify into 16 and 2, right? So we get I square root of 16 square root of 2, and then square root of 16 becomes 4. So you get x equals negative 2 plus or minus 4i square root of 2 over 2. And now the difference between this answer and the answer that we got by completing the square is that this one, you need an extra step to simplify it, right? So this one, we need to actually split it up. So we get -2 over 2 plus or minus 4i square root of 2 over 2. All right, -2 over 2 becomes -1, so we get x equals -1 plus or minus, and we can simplify 4 and 2 to become 2i square root of 2. All right, so we get the same answer, right? It's really up to you. In this case, I mean, the quadratic formula is reliable. It's always going to work. But if you're comfortable with completing the square, you should be able to recognize when would be useful to do it. In this case, it would, because our middle term is even, right? If you remember from the lesson on completing the square, I said that the best time to use it is when the first term, you have a equals 1, and you have an even b term, right? And we have that here, right? And it actually worked out pretty nicely. All right, so now let's do the last one. All right, so number 8. Now we can first get the squared expression by itself, right? So we want to get rid of that 3 out front just by dividing by 3 to both sides. So we should get x minus 1 squared equals -16 over 3. All right, and then to get rid of that square, you just want to square root both sides. All right, so then you should get x minus 1 equals plus or minus the square root of -16, right? Maybe you can do it now. Should get you 4i, right? Because the square root of 16 is 4, and we have that negative under the radical. We want to replace that with an I. So we get plus or minus 4i over square root of 3. Right? If you're not okay with that right away, this becomes the square root of -16 over the square root of 3. And then the square root of 16 we should simplify as the square root of -1 times the square root of 16. And then from there we get our answer, right? So if you just need to write it out, right, write out every single step, that's fine, right? It's whatever works best for your brain, right? So now we want to get the 1 to the other side. So we get x equals 1 plus or minus 4i over square root of 3. But we don't want that radical in the denominator. Remember, radicals in the denominator are not simplified. All right, so to simplify it, we need to rationalize the denominator. To rationalize it, you multiply the top and the bottom by that radical. All right, so then square root of 3 times square root of 3 just becomes 3. And then on the top, 4i times the square root of 3. All right, you just leave that alone, right? So we get x equals 1 plus or minus 4i square root of 3 over 3. All right, and that should be your answer. All right, so use any method. You should be able to recognize what method would work best in each situation. Right, if you love the quadratic formula, right, you could always, right, and I would advise against this just because you might run out of time, but you could always simplify this entire expression, like foil it out and then get the -16 to the other side, and then you'll have something in standard form that you can take that you can use the quadratic formula with, right? But some of these questions are set up like this for a reason, right? Some of them should not require as much work using one method versus another, right? So use your best judgment. All right, practice these kinds of problems so that you can, 1, do them efficiently, and 2, do them accurately. All right.